Have you ever gazed up at the night sky on a clear, moonless night and truly pondered the profound question of why it's so dark? Why isn't the inky blackness ablaze with light, despite the countless stars, each a sun in its own right, scattered across the cosmos? It seems like a simple question, but the answer is far from straightforward. The darkness between the stars, a seemingly obvious observation, has puzzled thinkers and scientists for centuries, sparking debates and driving astronomical inquiry. This cosmic conundrum holds the key to unlocking a deeper understanding of our universe, its origins, its evolution, and its ultimate fate. Ancient civilizations, with their limited tools but boundless curiosity, saw the night sky as a canvas for myths, weaving intricate stories into the constellations. These legends, passed down through generations, reflected their understanding of the cosmos, their fears, and their hopes. But the darkness itself, the vast emptiness punctuated by pinpricks of light, remained a profound and unsettling mystery. What was it? What did it mean? Early astronomers, armed with increasingly sophisticated telescopes, meticulously mapped the stars, charting their positions and movements with unprecedented accuracy. Yet despite their growing knowledge of the celestial sphere, the fundamental question remained stubbornly unanswered. Why doesn't all that starlight emanating from billions upon billions of stars collectively fill the sky with an overwhelming, all-encompassing brightness? The answer, as it turns out, isn't just that space is mostly empty, that vast gulfs of nothingness separate us from the stars. It's a complex interplay of factors, including the universe's immense age, giving light time to travel from the farthest reaches of space. It's also about its almost incomprehensible vastness, the sheer scale of the cosmos dwarfing our everyday experience. The finite speed of light plays a crucial role, limiting how far we can see and how much light can reach us from the distant past. And perhaps most importantly, it's about the ongoing cosmic expansion, stretching the fabric of space-time and redshifting the light from distant galaxies. Therefore, the darkness we observe is not merely an absence, but a profound clue, a subtle whisper from the universe itself. It speaks volumes about the fundamental structure and the long, intricate history of the cosmos, from its fiery birth to its ongoing evolution. It's not simply an absence of light, a void to be ignored, but a rich tapestry woven with the threads of time, space, and the very laws of physics. It's a puzzle that has captivated and driven scientific inquiry for generations, pushing the boundaries of our knowledge and challenging our understanding of reality. Understanding why space is dark, grappling with this seemingly simple question, ultimately means understanding our own place, our own fleeting existence, within the grand, awe-inspiring drama of the universe. The night sky's darkness, therefore, is more than just a visual phenomenon. It's a gateway, an invitation to explore the grand narrative of existence. It's a journey into the very heart of cosmology, a quest to unravel the deepest mysteries of the universe. So let's embark on this journey together and explore the fascinating reasons why the universe, despite being filled with countless stars, remains, in so many ways, shrouded in darkness. To understand the darkness of space, we need to know how light works. Light travels in waves, and our eyes detect only a small range, visible light. For us to see, light must reach our eyes. If it doesn't, we see darkness. Stars are powerful sources of light, but space is unimaginably vast. The distances between stars and galaxies are so great that light from many of them hasn't reached us yet. When we look at distant stars, we see them as they were, sometimes billions of years ago. The darkness is partly due to the finite speed of light and the immense distances involved. Much of the universe's light is still on its way, or too faint for us to see. Have you ever gazed up at the night sky and wondered about the darkness that stretches out seemingly forever? Has the universe always been this dark? This vast expanse of black sprinkled with distant stars? Surprisingly, the answer is no. The universe we observe today, with its dark skies, is vastly different from its earliest form. In its earliest moments, mere fractions of a second after the Big Bang, the universe was an incredibly hot, dense, and brilliantly bright soup of fundamental particles and intense radiation. Imagine a cosmos filled with an unimaginable amount of energy, a blinding light permeating every corner of existence. For about 380,000 years after the Big Bang, a period known as the photon epoch, light was effectively trapped in a dense, glowing fog, constantly interacting with the surrounding plasma and unable to travel freely across the vast distances. It was a period of intense activity and energy. As the universe relentlessly expanded, stretching the fabric of space-time itself, it also gradually cooled, allowing atoms to finally form. Protons and electrons combined to create neutral hydrogen, and light was finally able to move unimpeded through the cosmos. This pivotal moment, when the universe transitioned from opaque to transparent, is called recombination. The light that was released during this era, the afterglow of the early universe, is still traveling through space today, and we observe it as the cosmic microwave background, CMB, a faint but pervasive signal, now stretched into microwaves by the relentless cosmic expansion, a phenomenon known as redshift. If our eyes were sensitive enough, if we could somehow perceive microwaves, the entire sky would appear to glow with this ancient afterglow, a testament to the universe's fiery beginnings. After recombination, however, the universe entered a period known as the Cosmic Dark Ages, a time before the very first stars had a chance to form and ignite. During this extended time, the universe was truly dark in visible light, devoid of any luminous sources. Only when the first generation of stars finally ignited, their nuclear furnaces blazing, did the cosmos slowly begin to light up again, emerging from its extended period of darkness. The darkness we observe in the night sky today is a direct result of this long and complex cosmic evolution, a journey from a blindingly bright beginning to an era of darkness, and finally, to the gradual illumination we see around us now. The night sky's darkness, therefore, is not just an absence of light, but a relic, a faint echo of the universe's dramatic and ever-changing light history. What does the future hold for the darkness of space? The universe's expansion is accelerating, pushing galaxies farther apart and redshifting their light beyond what we can see. Eventually, distant galaxies will recede faster than light can reach us, disappearing from view. Within our local group, stars will continue to shine, but not forever. Stars have finite lifespans. Over trillions of years, they'll exhaust their fuel and fade away. New star formation will dwindle as raw materials run out. The universe will grow colder and darker as existing stars die and galaxies vanish from sight. The faint glow of the CMB will become even more undetectable. The ultimate fate of cosmic light is a universe of increasing darkness. It's a sobering yet fascinating glimpse into our cosmic future. The darkness of space, often perceived as an empty void, is actually full of hidden wonders and untold secrets. It's a canvas upon which the universe paints its most spectacular displays, a realm where the faintest glimmers of light tell stories of cosmic proportions. Space isn't truly empty. It's teeming with activity and energy, far from being a desolate nothingness. It's filled with faint glows, subtle emanations of light that whisper of distant stars and energetic processes occurring across vast cosmic distances. These faint glows are like embers in the darkness, hinting at the immense fires burning throughout the universe. Gas, dust, the raw materials from which stars and planets are born, swirling and coalescing in the interstellar medium. Dark matter, an invisible substance that makes up a significant portion of the universe's mass, and dark energy, a mysterious force driving the accelerating expansion of the cosmos. These enigmatic components shape the very fabric of space-time. The extragalactic background light, a cosmic echo of all the stars that have ever shone, is the sum of all starlight ever emitted throughout the history of the universe, a faint but persistent reminder of the luminous past. But it's too faint for our eyes to perceive directly, a subtle whisper drowned out by the brighter lights of our immediate cosmic neighborhood. Dark matter and dark energy, invisible yet dominant forces, exert a profound influence on the universe's structure and evolution. They shape the universe's fate, dictating how galaxies cluster together and how the cosmos expands into the future. Our eyes see only a tiny slice of the electromagnetic spectrum, a narrow band of colors amidst a vast ocean of invisible radiation. Much of the universe shines in invisible wavelengths, revealing hidden structures and energetic phenomena that are beyond our direct perception. If we could see in infrared or X-rays, if our eyes were sensitive to these hidden frequencies, the night sky would look dramatically different, transformed into a vibrant tapestry of unseen colors and energetic emissions. The darkness is a perfect backdrop, an essential canvas for observing faint, distant objects that would otherwise be lost in the glare of brighter sources. Without it, we couldn't study galaxies or nebulae located billions of light years away. their faint light struggling to reach us across the vast expanse of space. Every dark patch, every seemingly empty region of space, is a window to the distant universe, offering a glimpse into the cosmos as it existed billions of years ago. The darkness is essential for our exploration of the cosmos, allowing us to unravel the mysteries of the universe and understand our place within it. Olbers' paradox asks, if the universe is infinite and filled with stars, why isn't the sky bright everywhere? Early theories suggested dust blocked the light, but dust would eventually glow too. The real answer lies in the universe's finite age and its expansion. The universe began with the Big Bang about 13.8 billion years ago, so light from farther away hasn't reached us yet. There's a cosmic horizon. Beyond it, we can't see. The expansion of space also stretches light, shifting it out of the visible range. Distant galaxies' light is red-shifted and dimmed, contributing little to the sky's brightness. The finite age and expansion of the universe elegantly solve Olbers' paradox. That's why, despite infinite stars, our night sky remains dark. The darkness of the night sky is a profound statement about our universe. It reveals the universe's finite age, vast scale, and ongoing expansion. The solution to the dark sky and Olbers' paradox reshaped our understanding of cosmology. The darkness is linked to the Big Bang, cosmic evolution, and the limits of our perception. It hides mysteries like dark matter and dark energy, driving scientific discovery. The darkness provides contrast, letting us see and study distant stars and galaxies. Looking up at the night sky connects us to the universe's grand story. The question, why is space dark, continues to inspire our journey of discovery.